So far we've set up all the things that we need for our file, and now we want to begin modeling. We're going to begin our modeling process with sanitary and vent. First off, in order to have a good view on our project, I'm going to open one of the elevations, specifically the east one. As in, I will be going to the project browser palette, then to the coordination discipline, and after that I'm going to open one of the elevations, of which I've opened the east. Now if we take a look over here, we notice that our building has some kind of a stair shape. So basically the least amount of surface goes to the last floor, and the surface increases as it goes down. Now in order to model the sanitary pipes, we could just begin with the top floor since it contains less amount of sanitary items. The sewage pipes will be collected by a riser, and their content goes to the lowest level. So to begin modeling, we could just start from the roof, where the rainwater is collected, or we could also decide to start from the lowest level. So first, let's go take a look at the plans we have, and go back to Revit to start modeling. Now I'm heading to the Files package, then open the Mechanical Plans folder, where we have some more folders, of which I'm going to open the one that has plan in it. And finally, I'm going to go into the Sewage folder. Our plans here are organized from the lowest level, -3, up to the roof floor plan, all of which I've already opened in AutoCAD, and now we can take a look at them and observe their content. Over here on the roof, we've got some rainwater floor drains, which are also at the center of the slope, where the water is collected and leads to the riser, and the risers are also numbered. They've got sizes. And for example here, the R stands for riser, and the RW is for rainwater, and so we know that the rainwater riser is number 3. Over here we've got riser number 2, and so the riser's numbers are continued, and we can also see the pipes' paths. Also over here we've got the mechanical room, where we have some pumps, and there's also a floor drain, and then over here we've got the chillers, where we can also see the floor drains for those areas, which once again connect and lead to the riser. We've also got a ridge over here, where the water is collected into a pipe, and then that collected water is going to be leading onto the roof, which leads to the floor drain, and the floor drain to the riser. Now if we take a look at the lower level, which would be the level 5, again we're going to have to assess the situation of these rainwater risers, which continue all the way down to the lowest level, where they're going to be operated on. And we could also see the sewage pipes, which are related to the bathroom area in this level. For example, in this restroom over here, we've got 2 western toilets, then a lavatory, as well as a floor drain. And exactly parallel to that, we've got another one on this side, and their pipes are gathered and collected at the riser. Now down here, we've got an air handling unit room. So it's a mechanical room with also a floor drain, and the floor drain leads to the riser. So this way we could just observe the plans we have and assess the positions of the items that need to be placed. This right here was the 5th floor, so now we're going to go lower to the 4th floor, where again we've got some restroom areas, where we've also got a pantry, and we can also see the risers, the pipe sizes, and the same thing goes for the 3rd floor, as well as the 2nd floor, and the same thing's going on in the 1st mid-floor, 1st floor, and we could just continue going lower in the levels till we reach the final level, which is the 3rd basement. Now for this level, we could say that we've got all of the content of all risers, and that just means everything that comes from all of the pipes in the building, from the very top all the way down here. So once again, if we take a look around here, we see that there's a gutter, inside of which there's a floor drain, and then the pipes continue all the way here, and finally reach the pit. So this pit right here is going to gather everything that's in all of the pipes. If we look closely, we can see that there's also a riser connecting to it, and from the side there's a floor drain connecting. So all of the building's pipes are gathered in here, and then from this pit we've got a discharge pipe with diameter of 110. Now if we follow this pipe, we can see that once again there's another pit connecting to this line, and there's another sump pit over here. And now we're going to continue all the way down, where we can find another sump pit, which finally ends at this riser. So if we take a look at the file symbols, we can see that this riser is not going downwards, and instead it's going upward. So let's go check it out in an upper level. Let me check the grid first. It's at grid 11. Now if we go take a look at this riser on the level above, here it is, grid 11. And as you can see, this riser is going up, from which this pipe will be installed on the ceiling, which finally goes out of the area. So this way we're going to have to check out all the rest of the pipes. For example, if we take a look over here, we can see that there are some riser pipes coming from above. And also if we take a look on this side, we can see that they're both installed on the ceiling, connecting over here, and finally leading to discharge. Also on this side, we've got some more sump pits. And if we go all the way up, we can see that there's one over here, from which a discharge pipe is coming, and it goes all the way down and connects to another sump pit. And then the pipe goes on the ceiling, but it doesn't go up again, which means that it's going to discharge from the site, and finally gets to the city sewer. So to sum up, we're going to have to track down every single pipe that we have in the building and model each one of them with the right materials. Now about modeling these sanitary pipes, we could say that there are two types of them, one of which are the below ceiling pipes, and the other contains the risers. We're going to need to track all of the risers precisely, check where they start, where they go, and where they end, and just basically model them all the way to the sewer. To model the risers, we could also use the help from the riser diagram. For example, if I go take a look through the plans again, over here in the mechanical folder, we can see there's another folder called riser, inside of which we've got the riser diagram. Open in that file, we can see that we've got all of the mechanical risers of the building in one single file, and these are the sewage risers. For example, looking from the top, we've got riser number 1, where in the actually the second floor it changes directions, and then in the level below that, the riser ends at this point and connects to riser number 4. Now if we take a look at riser number 4, we can actually find the spot from which the riser number 1 is connected. So basically these two risers will be connected to each other at the second floor, and after that they become one. So this way we could track all of our risers not only from their plans, but also from the riser diagram. Now the first thing we're going to do is that we're going to link the plan into the top floor, and we're going to begin with the modeling process. And since we're going to be working with the top floor, we could start from the roof and model the polyethylene rainwater pipes. And after that, we're going to go to the lower level, which is the 5th floor, and then model these switch pipes, the material of which is polypropylene or push fit. Now, in order to link the plans into Revit, first I'm going to be using the linear command over here to measure one part of the items we have in this plan to check for the unit. For example, the width of this wall. We already know about a standard for wall widths, which is usually something around 20 centimeters, and just basically we've already got an approximate size of how wide walls should be. So I'm going to measure the width of one of the walls. Now the size that it shows here is 20, and I could figure that this 20 is in centimeters. That'll mean that the unit of this project is centimeter, because we got 20 for the wall, which is a standard that we already know about, that it is in centimeters. It can be 20 millimeters or meters, so centimeter is the one. But still there's something else we need to check. We're going to have to go to Dimension Style and make sure the style with which I measured is selected. Then I'll click Modify to check it. And here in the Primary Units tab, I'm going to have to make sure the scale factor is 1. Now let's say, what if hypothetically the scale factor was 10? That'll just make the values 10 times bigger. And for example, that 20 centimeter that we saw earlier would be 200 centimeters. And then we might think that it's probably 200 millimeters, and millimeter is the project's unit. So always check to make sure that your scale factor is 1. Now we know that we could link our plans with the centimeter unit. First, let's go check one of the plans. So I'm going to go over here and now to model the sanitary items in Revit. We've already created our floor plans, so we go to the plumbing discipline, then the sanitary and vent subdiscipline, and then double click on the roof floor plan to open it. Now we're going to head to the Insert tab, then click on Link CAD, and then I'm going to look through my mechanical files, then inside the plan folder, then Sewage, and since we're in the roof, we're going to select the roof plan. Now down here, we're going to make sure that we check the box for current view only, so that this link will be visible in this very plan. It says current view, which means that the view which is open, that is the roof. Now for the import units, we figured it out in AutoCAD, where the wall width was 20 centimeters. So I'm going to select centimeter, and then for the positioning, I'm going to select center to center, and finally I'm going to click open. Now we're going to have to place our plan in the right position by using the align command. Now if it was hard for you to discern your plan or pick from it, first you could go down here, then click on select links. Just make sure that the red X mark is not on it, so that it'll allow for your linked elements to be selected. Then you're going to grab your plan and move it to the side, and place it next to your model, and then use the align command. The shortcut to that command is AL, and now I'm going to select the grid 1 from the horizontal grids, then I'm going to click on grid 1 from the plan, and as for the vertical grids, for example, I'm going to select the grid C from the model, and then grid C from the plan. Now to make sure that the plan doesn't move around by mistake, we could just select it, then go up to the ribbon and click on the pin tool right here. So now while we're at it, it is best that we just continue linking all of the plans into their corresponding floor plans, because while we are modeling, we might need to check the risers, the pipe paths, and it'll be easier if all of the plans are linked. So I'm going to head to the 5th floor plan, go up to the Insert tab, select Link CAD, then select the plan for the 5th floor, and we're going to use the same settings as before, like current view only, centimeter, center to center, then click open. Now also, if you could discern your plan, you could just use the align command right away, so it's not necessary to move it to the side. Just activate AL, then align the A grids together, then align grid 1 with grid 1. After you've aligned them together, you could click on your plan and pin it. So we're going to continue linking all the plans the same way.